This is the demo for lesson 6 for college algebra. Systems of linear equations in two variables. So the examples we've worked so far have been solved using one linear equation with just one unknown, just one variable, usually x. So we're going to expand our ability to solve problems by reviewing how to create and solve systems of linear equations where you have two variables, which we call a linear system. So the graph below represents this system of equations. So we have two lines. The red line represents x plus 2y equals 142, and the blue line represents negative 3x plus 10y equals 160. So the blue line models the percentage of never married adults, and the red line models the percentage of U.S. married adults. So I want to estimate the coordinates of the common solution, the intersection point for the two lines. So it's right here, and it looks like it's at about, let's see, the x is just before 70, and the y looks like it's just before 40. So I'm going to say 68, 38. It's just an estimate. What does the intersection point tell us? Be sure to describe both variables being graphed with appropriate numbers and units. Okay, so 68 is years after 1970. So let's see what year that is. I'll do 1970 plus 68. So the year 2038. In the year 2038, the percentage of married adults and never married adults will be equal, okay? They are both about 38%. The percent of married and never married are both 38%. Why doesn't that add up to 100%? Because there are people who have been married but no longer are. Okay, so these don't always add up to 100%. So the solution to the system of linear equations was found visually by graphing. However, we could only approximate the solution of the intersection point. We couldn't get a very good value here because we didn't the scale wasn't helpful enough to give us exact values. So we're going to review two algebraic methods, substitution and addition, also known as elimination, that allow us to find the exact solution for a system of linear equations in two variables. So first, substitution. We pick an equation and solve for one of the variables. So I tend to pick the equation that has a variable that's easier to solve for. I like this first equation. I like that the coefficient on x is the 1, so I'll be able to solve this for x in just one easy step. So I'm going to start with x plus 2y equals 142. Subtract 2y from both sides, so I get x equals 142 minus 2y. Then I use my other equation, has to be the other equation, negative 3x plus 10y equals 160, and anywhere I see an x, like right here, instead of writing x, I'm going to write this expression with y in it, okay, because x and this expression are the same, so I can substitute one for the other. So I'm going to have negative 3, and instead of x, I'm going to replace it with 142 minus 2y. Plus 10y equals 160. And then now my equation has only one variable in it, just a y. I can solve for y. So distribute that negative 3, and I get negative 426 plus 6y plus 10y equals 160. So 160 plus 426 is 586, and 16y, and then divide both sides by 16, and I get y is 36.625. So that is the percentage of American adults that we had estimated to be 38%, right? So I was trying to find the intersection point of these two equations. I know what it means, right? I know that the y-coordinate is the percentage of married and never married adults the same, are both. We estimated it to be 38%. It's actually 36.625. Pretty close estimate, but this is the exact value. And then if I want the x, if I want to know what year it is, we estimated that was about 68. Let's see what x is if I go back and plug in the y. So I have x equals 142 minus 2 times the y, which is 36.625. So x comes out to be 42 minus 2 times 36.625, 68.75. So that's the year. Okay, so we had estimated 68, which is the year 2038. So it was a pretty good estimate, but it's, to be more exact, we could say 68.75 years after 1970. Next, we have the addition method, also known as the elimination method. We want to eliminate a variable by adding the two equations together. So I'm going to take my first equation, x plus 2y equals 142. And my other equation I'll write underneath it, negative 3x plus 10y equals 160. Now what I want to have happen is that I want to add the two equations together and have one of the variables go away. So right now I have x plus negative 3x would give me negative 2x, 2y plus 10y would give me 12y. I'd still have x's and y's. But what I can do is multiply both sides of one of these equations by the same thing and get an equivalent equation. So if I look at this first equation and multiply it by 3, right, then my new equivalent equation would be 3x plus 6y equals 426. And then I can add these two equations together. When I add these, okay, my negative 3x and my 3x cancel. I have no x's left. And I have 16y equals 586, which tells me that y is 36.625. Same thing I got using substitution. And then x, we would do the same thing. Pick either equation, x plus 2y equals 142. You can also pick the other equation. And now plug in the y that you know. X plus 2 times 36.625 equals 142. And we solve for x, and we will get 68.75. Solving a dual investment problem. So the optional exercises at the end of the lesson 5 activities went through this using only one variable. Today we're going to do it with two variables. So you have a scholarship fund that has $10,000 in it. We can invest in two funds. One's lower risk, one's higher risk. From the low risk fund, we can expect 4% annually, and from the high risk fund, we'll get 8% annually. We want to have an expected return of $550 a year. How much should we put in each fund? So step 1, what is the problem asking you to find? How much in each fund? Okay, so how much in low risk and high risk? How much in low, how much in high? Okay, so we're going to use two variables to identify each of these quantities because they asked us two questions. You can do this with only one variable, but sometimes it's easier if you're asked two questions to just use two unknowns. So let x be the amount in the low risk, and we'll let Y be the amount in the high risk fund. And what other quantities are mentioned in the problem? Interest. Okay. So I want to express each of these quantities in terms of X and Y and describe them in words. So low risk interest, that would be 4% of however much we invested, right? So this would be 0.04 times X, because we invest X in the low risk. And then high risk interest, the high risk gets 8%, and so we do 8% of the amount we put in the high risk fund, which is Y. And then what equals what? Well, our total interest is $550 a year. So I'm going to take my low risk interest plus my high risk interest, and I want them to total $550. And then we solve the equation for X or Y using the one value to solve for the other. Okay, so I need another equation because, right, it says what equals what. So I've got an interest equation, but if you have two unknowns, you need two equations. Okay, so this is my interest equation. I have another equation. There's another piece of information I haven't used yet, and that's the $10,000. I had a total of $10,000 to invest. So the amount I put in low risk plus the amount I put in high risk should add up to $10,000. So that's my second equation. X plus Y equals 10,000. And then we solve the system. We can either solve by substitution or elimination, whatever feels comfortable for you. I'm going to go with substitution, and you can solve either equation for X or Y. So I'm going to pick this one. It's much easier to solve for X or Y than this one. So let's see, I'll say Y is 10,000 minus X, and then I can plug that Y into my other equation. So 0.04X plus 0.08, and instead of Y, I'm going to put 10,000 minus X, because those quantities are equal, equals 550. And now I have an equation with only one unknown in it, an X. So I can solve this. I'll start by distributing the 0.08. So 0.04X plus 0.08 of 10,000 is 800 minus 0.08X equals 550. And then 0.04 minus 0.08 is negative 0.04X. 550 minus 800 is negative 250. And divide both sides by negative 0.04. And you get 6,250. So that's the amount we put in the low risk. Okay, $6,250. We put the rest of the 10,000 into the high risk fund. So we do 10,000 minus 6,250, and we get 5,250. That doesn't seem right. 10,000. I did 1,000. That's why. Okay, 10,000 minus 6,250, and we get 3,750. So we invest 6,250 in, that's X, which is the low risk fund. And the rest of our money, 3,750, in the high risk fund. And that will result in $550 of interest per year. Some students find this little table setup helpful for coming up with the equations here. So we have the lower rate fund, the higher rate fund, the total, the amount invested, how much interest, what the percent interest is, and the amount of interest. So we just pick variables. We say, well, let X be the amount we invest at the lower, and Y be the amount we invest at the higher, and the total invested is 10,000. And then our interest rate is 4% and 8%. And then you multiply across to get the amount of interest. So we have 0.04x and 0.08y. And then when you add the amount of interest together, we're supposed to get $550. And then we get our equations from column 1, x plus y equals 10,000. And column 2, 0.04x plus 0.08y equals 550.